So, good afternoon guys. Our topic for today is all about isentropic process. So, isentropic process, kung mapapansin nyo sa picture, isa yung hermetic compressor. Yan yung compressor na ginagamit sa um, sa mga refrigerator. Okay? So, isentropic process, ito yung process na ginagamit or ito yung process na kung saan yung change in entropy natin is equal to constant. So, isentropic, pwede siyang gamitin sa compressor, pwedeng gamitin sa turbine, or insulated purposes. So, itong process na to ay gamit na gamit sa refrigeration cycle. Okay? So, for the formula, yung anim pa rin ang ating gagamitin. Okay? So, heat natin, pwede siyang integral of TDS, limits from 1 to 2. Pwedeng in terms of delta U plus work non-flow. Work non-flow natin, integral of PdV, limits from 1 to 2. Of course, yung ating change in internal energy, mCV delta T. Change in enthalpy, mCp delta T, and work steady flow is equal to negative integral of BDP, limits from 1 to 2. Okay? So, overall, ang formula lang na ginagamit natin sa ideal gas processes ay 6 lang. So, I hope na marunong na kayo mag-derive as of this moment. Okay? Kaya sa i-memorize nyo yan lahat, ang dami na. Okay. So, dun muna tayo sa ating tinatawag na PB TS diagram. So, kapag constant entropy, eto yan. So, from process 1 to 2, the work under the PB diagram is the work non-flow. Then, maggawa ka ng line dito. Ito yung ating work steady flow. So, gawa ko ng line na. Hindi ko lang alam kung pantay yan. Pero gawa tayo ng line. Okay yan. Yan. So, ito, area na to, yan ang tinatawag natin na work steady flow or the area beyond the PB diagram. Then, since wala tayong area sa TS diagram, therefore, ano ba yung nabubuong area natin sa TS diagram? Di ba dapat supposedly heat yan? So, since wala tayong area sa TS diagram, kasi nga constant ang ating entropy, therefore, dapat ang heat mo dyan ay 0. So, wala tayong heat transfer sa constant entropy process. Okay? Okay. So, dun muna tayo sa PBT relationship using the... Ngayon, ibang formula na. Since entropy yan, ang formula na nagagamitin natin ay P1V1 raised to K is equal to P2V2 raised to K. So, ang volume natin ay nagkaroon lang ng raised to K. Okay? Kasi nga, ang pinaka-general formula natin, PV raised to N is equal to C. Tama? Since kapag isentropic, ang N natin ay laging equal to K. So, di ba, dapat P1V1 raised to N is equal to P2V2 raised to N. Ngayon, ang formula natin dito ay P1V1 raised to K is equal to P2V2 raised to K. Okay? So, nagkaroon lang ng raised to K sa ating V1 and V2. In terms of temperature, kapag inano mo to, sinimplify, ito yung madiderive natin na formula. T2 over T1 is equal to P2 over P1 raised to K minus 1 over K is equal to P1 over P2 raised to K minus 1. Etong isentropic, gamit na gamit to sa combustion engineering, which is iti-take nyo next time. Okay? Tsaka lahat naman ng process, lahat ng ideal gas process na diniscuss natin is magagamit nyo sa combustion engineering. Okay? So, dalawang formula natin na P1V1 raised to K is equal to P2V2 raised to K. In terms of temperature, T2 over T1 is equal to P2 over P1 raised to K minus 1 over K is equal to P1 over P2 raised to K minus 1. Meron ako ditong coding eh. Ano bang coding ko dito? T2, PP2, kick. Diba? Tapos yung B1 over B2 raised to K minus 1 na lang. T2, PP2, kick. So, P2, PP2, kick. So, yun yung aking coding dyan. Okay? In terms of work non-flow, yan yung area under the PV plane. So, yun pa rin, formula na gagamitin natin ay integral of PDV limits from 1 to 2. Where PV raised to K is equal to C. Diba? Kung sa tatlong process na nauna natin, PV raised to N is equal to C. Ngayon, PV raised to K is equal to C ngayon. Okay? I-multiply natin both sides by V raised to negative K. No? So, makakancel to. P is equal to C V raised to negative K. Okay? So, ito, substitute natin dito. Therefore, work done flow is equal to integral of C V raised to negative K. Yan yung P natin. Pinalta lang natin ng value. Then, copy yung ating dV. Since constant yung ating C, labas natin. Is equal to C, integral of V raised to negative K dV. Limits from 1 to 2. Okay? Okay. Then, after that, di ba kapag nag-integrate tayo, maglalagay tayo dito na plus 1 over, copy natin yung negative K plus 1 sa ating denominator. So, kapag in-integrate natin yan, copy mo yung C, V raised to negative K, so magpa-plus 1 ka, kasi nga integral, over, copy natin yung ating exponent, which is negative K plus 1. So, limits from 1 to 2. Then, after that, paano ba natin yan isi-simplify? Yung C natin, itong C pwede nating ibalik sa PB raised to K is equal to C, no? So, palitan natin to ng PB raised to K. Therefore, work non-flow is equal to PB raised to K, V raised to, ito, ipagpalit lang natin, 1 minus K. Parang sinimplify lang natin yan. Hindi naman nabago yung sign, no? Then ito, 1 minus K din. Yan. Dinisarrange lang natin, pero yung sign ganun pa rin. Wala naman tayong binago dyan. Nag-disarrange lang tayo. Okay? Then after that, pwede natin i-simplify. Ito kasi, pwede mo siyang i-write as V raised to 1 times V raised to negative K. Right? Rules of exponent. Okay? So, ito nire-write natin over 1 minus K. Okay? So, cancel yung negative K, V raised to negative K, tsaka V raised to K natin. Therefore, ang matitira na lang dyan, PV, P na lang, di ba? Tapos dito V. Kasi V raised to 1 is equal to V. Then, 1 over K, limits from 2 to 1. Okay? So, yung 2, substitute natin sa PB. So, magiging equal siya sa P2V2 minus P1V1 over 1 minus K. Okay? Okay. So, ito na yung isa nating formula. So, pakitandaan to. So, kapag work non-flow pala, kapag constant entropy, work non-flow is equal to P2V2 minus P1V1 over 1 minus K. Since meron tayong formula na PV is equal to MRT, pwede natin siyang i-write in terms of MRT. Therefore, pinaka-formula natin ay MR, T2 minus T1 over 1 minus K is equal to P2, P2 minus P1 over 1 minus K. Okay? Paano naging MR T2 minus T1? Di ba ito? P2 B2 minus P1 B1 magiging MR T2, okay, minus MR T1. Okay? Since yung MR natin ay constant naman yan, parehas lang yan dito, lalabas mo as common factor. MR T2 minus T1. Yan. Kaya siya naging ganyan. MR-T2 minus T1 over 1 minus K. Copy mo lang yung 1 minus K. Okay? So, work non-flow, yung dalawang formula lang ang ating kailangan. Then, sa heat naman, di ba pinakita ko kanina yung TS diagram? Since walang area na na-form, therefore, heat natin is equal to 0. Okay? Kasi yung heat natin, nakadepende sa entropy. Mas mataas yung heat, mas mataas yung entropy natin sa isang object. Okay. Next. When it comes to internal energy, same pa rin yan. MCV delta T is equal na siya sa negative work non-flow. In terms of enthalpy is equal to MCP delta T, pwede rin siyang in terms of negative work steady flow. Okay? In terms of entropy, wala tayong change in entropy kasi constant entropy process tayo. Therefore, it is equal to 0. Now, i-derive natin tong delta H. Bakit naging equal siya sa work steady flow? Delta U, automatically equal siya sa negative work non-flow kasi nga delta U is equal to, burahin ko lang okay. Nagdikit Kaya siya equal sa work non-flow kasi delta U natin ay heat minus work non-flow. So, heat nga natin ay 0, kaya pwede siyang equate as negative work non-flow. Kapag sa enthalpy naman, paano siya na-derive? So, from the general equation, ito 0. Okay? Ito 0. Ito 0. Then, ilipat mo yung work steady flow sa kabila. Therefore, or enthalpy pa rin nilipat ko, no? Work steady flow is equal to negative delta H or delta H is equal to negative work steady flow. Parehas lang yun. So, work steady flow natin equals sa negative enthalpy. Now, i-derive pa natin by using the integration. So, work steady flow by using integration, gamitin natin yung formula na negative integral of VdP limits from 1 to 2. Okay. Since meron tayong equation na PB raised to K is equal to C, i-multiply natin both sides of the equation by the power of 1 over K. So, kapag ito minultiply mo sa 1 over K, ang lalabas niyan ay P raised to 1 over K, then yung K dito, tsaka 1 over K magka-cancel kasi equal to 1 lang naman yan. Is equal to C. So, any value raised to any constant, paano ko ba explain? So, kahit anong value ang ilagay natin dito sa constant, still constant pa rin siya. Parang sa, ano natin, di ba? Sa differential equation. A constant raised to any power is equal to constant pa rin. So, yun. Okay? Okay. So, i-write natin siya in terms of V. Okay? Kasi ito yung papalitan natin eh. Yung V. Kasi hindi naman siya related sa D. Okay? I-write natin in terms of P. V is equal to C P raised to negative 1 over K. Okay? Kasi nilipat mo to dito, magiging negative exponent na siya. Okay? Or pwede ring C over P raised to 1 over K. Parehas lang naman yun. So, rules of exponent. So, since meron na tayong value ng P, substitute na natin dito. Therefore, work steady flow is equal to negative integral of Cp raised to negative 1 over K. Ito yan, pinalitan lang natin yung P. Then, copy natin yung dito. So, constant, laging nilalabas. Therefore, negative C. Limits from 1 to 2. Ano na ako sa... Okay. Therefore, negative C. Integral of P raised to 1 over K dP. Limit from 1 to 2. Okay? Yan ang ating working equation. Okay. So, kunin natin ang tawag dito, ang integral nito. So, kapag kinukuha natin yung integral, magpa-plus 1 tayo dito sa exponent. Then, kung ano yung exponent niya, ikakopy lang natin sa denominator. Okay? Therefore, ano nga yung C natin? Ito pala yan. C is equal to P raised to 1 over K times V. So, yung C natin, pinalta lang natin ng P raised to 1 over K times V. Okay? Baka malito Then, copy yung negative sign. Ito, in-integrate natin. So, P raised to negative K plus 1. Then, yung ating power or exponent, ikakopy lang natin sa denominator. So, basic integral or basic integration. Okay? Limits from 1 to 2. Okay, simplify pa natin. Etong ilalim, ano ba magandang gawin dito? Pwede mo siyang i-LCD. Then, after that, etong P raised to negative 1 over K plus 1, pwede mong gamitan ng rules of exponent. Diba, ito, pwede mo siyang i-write as P raised to negative 1 over K times P. Okay? So, kapag minultiply mo yung ating P raised to negative 1 over K dito sa P raised to positive 1 over K, ang matitira na lang ay P. So, PB, so negative PB, wala na to, no? Negative PB over, kunin natin yung LCD. Oh, bitaw na yun. Ayan. So, copy mo yung negative, PB na lang siya. Kasi nga, na-cancel yung P raised to negative 1 over K. Tsaka, eto. Natira na lang ay P. Then, copy mo yung V over LCD nito ay negative 1 plus K over K. Okay? Limits from 1 to 2. Therefore pala, kapag sinimplify natin to, ang kalalabasan niyan, itong K, lalagay mo sa taas, kaya siya magiging negative K. P2V2 minus P1 over negative K, negative 1 plus K. Okay? Therefore, ilabas natin yung negative nito. So, magiging 1 minus K. Multiply natin sa negative sign. So, inano natin. Ang tawag doon? Nilabas natin yung negative. So, cancel yung negative. Kaya, ang magiging working equation mo ay K, P2B2 minus P1B1 over 1 minus K. Or, look similar siya sa, di ba? work non-flow natin. Ano nga formula nun? P2V2 minus P1V1 over 1 minus K. Okay? So, ito, i-write mo siya in terms of work non-flow. Therefore, work steady flow pala ay K times work non-flow. Yun lang pala yun. So, kapag may nabasa kayo na compressor, insulated purposes or turbine, automatic isentropic process yan. So, hindi naman sinasabi sa problem na constant entropy, minsan sinasabi yung etong tatlo. So, either doon, yun na yung palatandaan nyo na isentropic process yung isang problem. So, let's start or let's go to the sample problems. Number 1. From a state defined by 300 psia, 100 cubic feet and 240 degrees Fahrenheit, helium undergoes an isentropic process to 0.3 psi gauge. Find V2 and T2, delta U and delta H, integral of PDV, negative integral of PdP, heat, and delta S. What is the work if the process is non-flow and if the process is steady flow with delta K is equal to 10 BT? So, kunin natin yung given. We have, so sinabi dyan is isentropic process. So, gagamitin natin yung formula na dinerive natin kanina. Okay? So, okay. So, kunin natin yung given. S is equal to C, where the initial pressure is 300 psi absolute. Initial volume is 100 cubic feet. T1 is equal to 240 degrees Fahrenheit. So, convert natin in terms of Rankine. We have 240 plus 460 is equal to 700 degree Rankine. Then, final pressure is 0.3 psi gauge. So, since gauge yan, gawin natin absolute by adding 1 atmosphere or 14.7 psi absolute. So, magiging 15 psi absolute. Now, ang hinahanap natin ay P2 and T2, delta U and delta H. Work non-flow. Bakit naging work non-flow? Kasi integral of PdB. So, baka malito kayo, pinapahanap yung value ng integral of PdB, ibig sabihin lang nun, work non-flow. So, kapag pinahanap negative integral of VdP, ibig sabihin lang nun, work steady flow, then, napin daw natin yung heat and delta S if the process is non-flow and steady flow. Okay? So, yan. Sorry. Iba pa pala yun. So, yung heat natin, hinahanap tsaka delta S. Tapos, hinahanap ano daw yung work kapag ang process natin ay non-flow. Okay? And kapag steady flow. So, kaya may frame yan kasi yan yung actual na work na hinahanap. So, work non-flow actual and work steady flow actual if kinetic energy or change in kinetic energy is equal to 10 dB. Okay. So, solution tayo. Kunin muna natin yung V2 and T2. So, kasama to sa table or mga constant na binigay ko. So, kailangan memorize yan. Where yung K ng helium ay is equal to 1.667. Solving for, ano bang dapat? B2 muna, no? Gamitin natin yung formula kanina. P1V1 raised to K is equal to P2V2 raised to K. So, importante na memorize nyo yung mga constant kasi kapag hindi nyo memorize yung constant, dito pa lang, stop na kayo, hinto na kayo. Okay? Hindi pwede manghula ng constant kasi unti lang yung diferensya niyan eh. Kahit decimal yung diferensya ng mga K natin, kapag sinubstitute mo siya sa mga equation, malaki yung value na difference na magagawa. Kaya, nonsense din kapag hindi mo memorize ang mga constant. So, paki-memorize yung mga constant na binigay ko. Especially yung K and yung molecular weight, no? Then yung mga R. Importante yon sa thermo. Di lang sa thermo, pati sa power plant and other major subjects. Okay, so, meron tayong P1, meron tayong B1, meron tayong K, and meron tayong P2, so direct sub lang. Okay? So, P1 is 300, P1 is 100, raised to K, which is 1.667, is equal to P2 is equal to 15, then copy yung V2 raised to K, which is 1.667. So, shift solve sa calcu, meron tayong B2 of 603.201 cubic feet. Now, solving for T2, gamitin natin yung isang formula, which is T2 over T1 is equal to P2 over P1 raised to K minus 1 over K, or T2 PP2 kick. T2 PP2 kick. Okay? T2, i-cross multiply natin tong T1, no? Para masolve natin yung T2. T2 natin, so kinross multiply to. Ito na yung T1, 700. P2 natin is 15. P1 is 300 raised to K, which is 1.667 minus 1 over 1.667. Therefore, T2 natin ay 211.120 degree lang tayo. Or, in terms of Fahrenheit, T2, since maliit na letter yan, dapat Fahrenheit ang sagot natin. Negative 248.88 degrees Fahrenheit. Okay. Now, for the change in internal energy, solve muna natin yung mass para makuha natin yung dalawa. So, from PBMRT or P1B1 over RT1, cross multiply lang yan, galing yan sa PBMRT. So, meron tayong apat na yan na value. Okay? So, given yan sa problem, which is yung P1 is 300 PSIA or pounds per inch squared. Then, kailangan yung inch natin in terms of feet para compatible siya sa ating volume, which is cubic feet. Okay? So, 144 inch squared is equal to 1 feet squared. Then, copy yung volume 1 which is 100 cubic feet. Then, R natin ng, helium. Okay? Is 386.04 foot-pounds per LBM degree lang tayo. So, ito hindi rin to given. Isosolve mo siya in terms of, ano bang formula ng R natin? R is equal to R bar or universal gas constant over the molecular weight. Molecular weight ng helium is 4 lang naman. Okay? Then, yung R bar natin, kapag English ay 1545 foot-pounds per LBM degree lang tayo. Ayan. So, dyan ang galing yung ating 386.04 foot-pounds per LBM degree lang tayo. Okay. So, T1 natin ay 700 degree lang tayo. Therefore, mass natin ay 15.987 pound mass. So, ito yung sinasabi ko kanina, 1545 divided by 4, which is 386 foot-pounds per LBM degree lang. So, since nakuha na natin yung mass, makukuha na natin sino ba muna? Enthalpy. And enthalpy is equal to MCP T2 minus T1. Since ang given natin ay R lamang, which is yung nakuha natin, and yung K, which is 1.667, kunin muna natin yung value ng ating CP and CV. So, anong formula ng CP natin? CP is equal to KR over K minus 1, which is K is equivalent to 1.667, R is 386.04 foot-pounds per pound mass degree ng kind, over K natin is 1.667 minus 1. Etong sa ilalim na to is conversion lang ng 1 BTU is equal to 778 foot-pounds. Okay? Cancel to. So, matitira ay BTU per pound mass degree Rankine. Type nyo yan sa calculator, lalabas na CP natin ay 1.24 BTU per pound mass degree Rankine. In terms of CV naman, pwede natin gamitin yung formula ng CP minus R, where meron tayong CP, 1.24 lang yan. Oh my God. Discard. Yan. Save na natin. Na-typo lang. Ayun. Okay? So, nandun na tayo sa pag-solve ng value ng CV. CV is equal to CP minus R. So, 1.240 BTU per pound mass degree Rankine. So, since yung R natin ay in terms of foot pounds, i-divide pa natin by 778 para unit-wise na tayo, same units na tayo. So, 386.04 divided 778. Therefore, CV natin is equal to 0.744 BTU per pound mass degree Rankine. Okay? So, nakuha na natin yung CP, nakuha na natin yung CV, makuha na natin si delta U and delta H. Okay. So, delta U tayo. M, which is 15.987, yung nakuha natin kanina. Ito. CV, which is 0.744 BTU per pound mass degree Rankine. Then, delta T is 211.12. Yan yung T2 minus T1, which is 700. So, by cancellation of units, so cancel yung ating pound mass and degree Rankine. Matitira na lang dyan dapat ay BT. Delta U is equal to negative 5,814.9 BT. Solving for delta H, we have mass of 15.987, CP of 1.24, and delta T of 211.12 minus 700. Same lang naman siya ng delta U. Nagkatalo lang sa CP and CB. So therefore, by cancellation of units, delta H is equal to negative 9,691.498 BT. Okay. Work non-flow natin, pwede natin siyang isolve in terms of P2V2 minus P1V1 over 1 minus K. So, ang ginawa natin dito ay minultiply na natin sa 144 para maging foot-pounds yung lalabas na units. Okay? Then, yung foot-pounds natin ay kinonvert na natin sa BTU. So, cancel to. Dapat ang units mo dyan ay BTU. Therefore, ito conversion lang yan. P2 mo ay 15 PSIA, V2 mo ay 603.201 cubic feet. Yan yung nakuha nating value kanina sa letter A. Minus 300, yan yung P1 mo, PSIA. Then 100 cubic feet, yan yung B1 or given sa problem. Over 1 minus K, 1 minus 1.667. Therefore, work non-flow is equal to 5,814.059 BTU. Actually, kahit hindi mo na nga ito gamitin yung formula, basta na-solve mo na yung delta U. Kasi by principle kanina, delta U is equal to negative work non-flow. Kaya kung negative work non-flow ang delta U, therefore, work non-flow mo is 5 positive value ng delta U. Okay? Pansin nyo, parehas lang sila. Nagkatalo lang yan sa decimal kasi dun sa process natin kanina. Pero same value lang yan. Ito positive, ito negative. Work non-flow is negative delta U. So, dyan natin na-prove na negative sign lang sila. Yung pagkakaiba nila. Okay? Now, for the work steady flow, gamitin natin yung formula ng K work non-flow. Wag na tong mahaba, no? um, nakakaubos ng oras. So, K natin is 1.667, then 5814.059 BTU. Therefore, work steady flow is equal to 9,692.036 BTU. Then, by principle or by concept, work steady flow is equal to negative delta H. Kaya, almost the same lang sila, no? Nagkatalo lang tayo sa negative sign. Now, for heat and delta S, parehas yan equal to 0 kasi constant entropy tayo. Constant entropy line also, walang nabuo na area. Now, for the work non-flow prime, ito na yung actual. So, sa actual, merong heat talaga yan, kaso minimal lang. Pero since hindi naman binigay, therefore, work non-flow natin, yung pa rin. Negative delta U. Now, for work steady flow actual, since nagbigay siya ng 10 BTU, i-add natin dun sa ating nakuha na work steady flow kanina. So, ito yung pinaka-general equation natin, no? Work steady flow is equal to Q minus delta PE minus delta KE minus H, or i-disarrange natin work steady flow prime is equal to Q minus delta PE minus delta H minus delta K. Okay? So, ito, equal siya sa work steady flow. Therefore, work steady flow prime is equal to, purahin lang natin, no? Work steady flow, itong tatlong yan, minus delta K. Okay? So, 9692.036 minus 10 is equal to 9682.036 BTU. Kung napansin nyo, di ba, kaya nilelekilek lang lagi yung delta KE kasi minimal value lang, maliit na value lang siya. Almost hindi siya makaka-affect sa ating process. Okay, so that's all for number 1. Doon tayo sa number 2. An adiabatic expansion of air occurs through a nozzle from 828 kilopascal and 71 degrees Celsius to 138 kilopascal. The initial kinetic energy is negligible. For an isentropic expansion, compute the specific volume, temperature, and speed at the exit section. So, given natin, P1I or initial pressure, 828 kilopascal. T1 natin ay 71 degrees Celsius. Ito. Then, gawin natin absolute plus 273 is equal to 344 Kelvin. P2 natin ay 138 kilopascal. Hinahanap ay V1, V2, T2, V2, and that's it. If kinetic energy 1 is equal to 0. Okay? Ito yan. The initial kinetic energy. So, initial lang ang ating negligible. So, yung Ke2 natin, supposedly dapat may value yan. Okay? Kasi sinabi initial lang, hindi change in kinetic. Magkaiba yun ha. Kapag sinabing change in kinetic, delta Ke yun. Ayan ang negligible. Pero kapag sinabing initial lang, Ke, kinetic energy 1 lang ang ating 0. Yung Ke2 may value yan. Bakit 0 sinulat? Question mark that. Yan, yung Ke2 natin dapat may value yan. Kasi initial lang ang ating negligible. So, solving for B1, B2, and T2 using the T2, P2 kit. Okay? So, direct sub lang yan. T2 is equal to, cross-multiply natin yung T1. T1 ay 344, P2 ay 138, P1 ay 828. So, since sinabi air, therefore K natin is equal to 1.4. So, K minus 1 is 1.4 minus 1 is equal to 0.4 over 1.4. Therefore, T2 is equal to 206.172 Kelvin. Solving for V1 using PB, MRT, then i-cross multiply lang din natin gaya ng ginawa natin kanina. So, ang lalabas dapat dito ay per unit mass kasi wala tayong given na mass. So, RT1 over P1, 0.287, yan yung R natin. 344, yan yung T1. Then, P1 is 828 kilopascal or kilonewton per meter square. So, cancel to. Cancel yung K. So, matitira, cubic meter, tataas yan, per kilogram. 0.119 cubic meter per kilogram. Okay? Solving for T2 using P1V1 raised to K is equal to P2V2 raised to K. Direct sub lang. P1 is 828, V1 is 0.119, P2 is 138. Since kilopascal lang naman yan, di ba? Tapos kilopascal lang din to, makakancel lang yan. So, matitirang unit ay cubic meters per kilogram. Then, V2 raised to 1.4, shift solve sa calcu. We have V2 of 0.428 cubic meters per kilogram. Now, ang hinahanap naman ay V2 if kinetic energy 1 is equal to 0. So, solving for V2, gamitin natin yung general equation ng heat is equal to delta PE, delta KE plus delta H plus work steady flow. So, since sinabi na no cell yan, therefore, work steady flow is equal to 0. Kasi walang work, hindi mo kailangan ng work sa nozzle. So, kung gusto niyo makita yung nozzle, i-search niyo na lang sa Google. Pero, makita niyo, hindi kailangan ng work doon. Okay? Heat, wala din. And delta PE is equal to 0. Therefore, delta K is equal to negative H. So, nilipat to sa kabilang equation, kaya naging negative. Where delta H is equal to CP, dapat negative CP yan. Sulat ko. Okay, pwede na yun. Ay, sorry. So, negative CP, yan. Negative dapat yan. T2 minus T1. Per unit mass kasi wala naman tayong mass na given. Therefore, delta KE is equal to CP natin ng air 1.0062. T2 natin kanina is 206.172 and T1 is 344. Okay? So, ang matitirang units ay kilojoules per kilogram. Therefore, delta KE is equal to 138.683 kilojoules per kilogram, or in terms of joules, 138,683 joules per kilogram. Now, paano natin masasolve si V2? Ang V2 na yan ay, velocity. Okay? Kasi, ang function ng kinetic energy ay in terms of velocity. Kasi ang formula niyan ay 1/2 mv squared, where yung v natin ay velocity. So, V2, velocity na. So, from the formula of delta KE is equal to KE2 minus KE1. So, since negligable yan, delta KE is equal to KE2 or mv2 squared over 2gc. So, since per unit mass, v2 squared over 2gc. Okay? So, i-cross multiply natin to para makuha natin yung value ng V2. Therefore, V2 is equal to, multiply, itaas lang natin to, 2GC times KE, then square root natin parehas. Okay? So, cross multiply lang yan, then kinuha yung square root. Therefore, V2 is equal to square root of 2GC times delta K. Substitute natin yung value. So, square root of 2, ang value ng GC natin kapag SI ay 1 kilogram meter per Newton second squared. Sorry. Okay? Ayan yung value ng GC natin kapag SI. Then, copy natin yung delta KE, which is equal to 138,682. So, by cancellation of units, cancel to Newton. Cancel yung kilogram. So, matitira dyan ay meter squared per second squared. So, since naka-square root, dapat ang unit ng velocity to mo ay meters per second kasi ini-square root mo siya. Therefore, kapag in-input nyo to sa calcu, ang lalabas ay 526.655 meters per second. Okay? So, that's all for isentropic process. Stay safe and thank you.